Welcome to the Deep Dive. We're the show that, well, digs into the sources you need to understand.
Taking the core ideas and making them accessible.
Exactly. And today, we're plunging into something pretty crucial if you're navigating modern software systems. The complexity is just incredible these days.
Oh, absolutely. Containerization, orchestration, it's a different world.
Think about it. Systems running thousands of containers managed by platforms like Kubernetes. I mean, how do you even start to interact with something like that?
Yeah, it's a real challenge.
Yeah.
Kubernetes itself, while powerful, is this, complex beast orchestrating everything. You need a way in.
And that's where Kubectl comes in, right? It's often called the essential tool, the key, maybe, the main way you talk to a Kubernetes cluster.
Pretty much, it's the command line interface, the CLI, that lets you manage, inspect, configure, basically do things with your cluster. For beginners especially, it's the first point of contact.
So our mission today in this deep dive is to really unpack Kubectl. What is it? How does it actually work behind the scenes? And why is it just, well, indispensable if you're working with Kubernetes?
Right, and we're basing this on insights from Kubectl, interacting with Kubernetes clusters, a really solid resource for getting to grips with it.
Okay, so let's zoom in. Kubectl. If Kubernetes is the, I don't know, the brain or the conductor,
Right.
what's Kubectl's specific job?
Well, if Kubernetes is the conductor, Kubectl is maybe your direct phone line to the conductor, or maybe the baton itself. It's that command line tool giving you direct control.
Okay.
Lets you manage the applications, check what's running, make changes. It's your main interface.
You mentioned it simplifies things. How does that actually, play out day to day for someone using it?
That's the beauty of it. Kubernetes clusters are inherently complex, right? You've got the control plane, worker nodes, pods running everywhere.
Lots of moving parts.
Exactly. Kubectl provides this intuitive layer on top. It acts as a bridge between you, the user, or maybe your scripts, and the Kubernetes API server.
The API server being the main control point.
Precisely. So instead of crafting raw API calls, which can be, frankly, a bit tedious and error-prone,
Yeah, I can imagine.
you just type a relatively simple Kubectl command. Kubectl translates it, sends it off, gets the response, and shows it to you.
What kind of commands are we talking about?
Oh, all sorts. You've got user-friendly commands to create resources like pods or deployments. You can update them, delete them, inspect them in detail.
Like checking logs or status?
Exactly. Viewing logs, checking resource usage, figuring out why something isn't working. It's crucial for debugging. Plus, managing cluster configs, checking node health, and it's even extensible with plugins for more advanced stuff.
Okay, so to really get it, maybe we should touch on the key concepts it interacts with. You mentioned the cluster, the API server.
So you have the Kubernetes cluster itself. That's the whole setup. Nodes running your containers, managed by the control plane.
Got it.
Then the API server, which is part of that control plane. It exposes the Kubernetes API. That's who Kubectl talks to.
Okay.
You interact with resources. These are the objects in Kubernetes, like pods, deployments, services, that define what you want running.
And you mentioned one other really critical piece earlier, the configuration file.
Ah, yes, the kubeconfig file. Super important. It's usually located at kubeconfig by default.
And what's in there?
It holds all the details Kubectl needs to connect. The cluster's API server address, like its URL, maybe https://cluster.example.com.6443, and your credentials. How does the cluster know it's you?
Right, authentication details. Tokens, certificates, that sort of thing.
Exactly. Tokens, certificates, maybe even username, password, though that's less common now. It's the key to the front door.
So basically, Kubectl is the universal remote. Makes sense. It lets you control things without needing an engineering degree in Kubernetes internals just to start.
Precisely. It lowers the barrier to entry while still being powerful enough for experts.
All right, so we know what it is. Let's pull back the curtain a bit more. How does it actually work? What happens when I type, say, Kubectl get pods and hit enter?
Okay, so under the hood, Kubectl is a client-side application. It runs on your machine or wherever you execute the command.
Right, not on the cluster itself.
Correct. It takes your command, like Kubectl get pods, and its main job is to translate that into a request that the Kubernetes API server can understand.
An API request?
Yep, a standard HTTP API request, actually. It figures out which cluster to talk to by looking at your kubeconfig file.
Ah, the kubeconfig again?
Always. It finds the server address and the authentication details from that file. Then constructs the correct API call in this case, probably a GGA request to a specific API endpoint for pods, adds your credentials for authentication, and sends it over the network, usually securely via HTTPS.
And the API server receives this.
The API server gets the request, checks if you're allowed to do what you're asking.
Authorization.
Right, authorization. Then it fetches the requested information, in this case, the list of pods, probably from etc. The cluster's database packages it up, usually as JSON, and sends it back to Kubectl.
And then Kubectl just shows it to me.
Well, it usually does some formatting first. That raw JSON isn't always super friendly. So Kubectl get pods typically formats it into that nice readable table you see on your screen. But you can ask for the raw JSON or YAML if you want, which is useful for scripting.
Okay, that makes sense. It's like a translator and a messenger combined.
A very efficient one, yeah.
You mentioned a few commands. If you had to pick, say, the top 3 or 4 essential commands for someone just starting out, maybe for basic daily tasks or troubleshooting.
Oh, good question. Definitely Kubectl get. You need to see what's running. Kubectl get pods. Kubectl get services. Kubectl get deployments. You'll use that constantly.
Okay, number 1.
Number 2, I'd say Kubectl describe. When Git shows you something exists, describe gives you the details. Like Kubectl describe pod myapp 1234. It shows events, status conditions, configurations. Super useful for figuring out why a pod isn't running, for instance.
Right, digging deeper.
Exactly.
Mm-hmm.
Third, probably Kubectl logs. Your application prints logs, right? This command lets you fetch them directly from a running container. Kubectl logs myapp pod. Essential for debugging.
Makes sense. Get, describe, logs. Anything else?
Maybe Kubectl apply a F. This is how you typically create or update resources from configuration files, usually written in YAML. You define what you want in the file, and apply makes it happen. It's more declarative.
Okay, and maybe Kubectl exec for running commands inside a container.
Oh, yeah. Exec is powerful, too, especially for debugging. Kubectl exec mypod bash drops you into a shell inside the container. Definitely useful.
So the big advantage here is this abstraction, right? Kubectl hides the complexity of direct API calls. What's the real impact of that?
It's huge.
Yeah.
It means you, the developer operator, can focus on the what application do I want to deploy? How many replicas do I need? Rather than the how do I construct this specific HTTP PUT request with the right JSON payload and headers?
Right. Less low-level fiddle-in.
Way less. It speeds things up immensely. Teams can iterate faster, manage applications more easily. It makes Kubernetes accessible, frankly. Without it, the learning curve would be much, much steeper.
Let's walk through a quick example workflow. Say I want to deploy a simple Nginx web server. I run Kubectl create deployment, my Nginx image Nginx. What's the sequence?
Okay, so you run that command. 1, Kubectl parses it, sees you want to create a deployment named my Nginx using the Nginx image.
Stew.
It looks up your current cluster context in kubeconfig. 3, it constructs a POST request to the API server's endpoint for deployments, including the deployment details. 4, it sends that secure request.
Yeah.
5, the API server receives it, authenticates you, authorizes the action. 6, it writes the new deployment object definition into Ethaflare.
Okay, it's stored now.
Yep, the desired state is recorded. Then, other parts of the Kubernetes control plane, like the deployment controller, notice this new deployment. 7, the controller creates a replica set, which in turn tells the scheduler to find nodes for the Nginx pods. 8, pods get scheduled and started on nodes.
That I can check.
Then you run Kubectl get pods. Kubectl sends another request, a KD this time, to the API server. The API server checks, etc., for the current pod status and sends that info back to Kubectl, which formats it for you. Hopefully you see your Nginx pod running.
Wow, okay. Seems simple on the surface, but there's quite a bit happening.
It's a well-orchestrated dance, definitely. But Kubectl makes it feel seamless.
You've mentioned security a few times, HTTPS, authentication, authorization. This seems really baked into the process. Let's dive into that secure conversation aspect.
Absolutely critical. It's all built on that client-server model we talked about. Kubectl is the client, the kube API server is the server, the gatekeeper for the entire cluster.
And the kubeconfig file is the key to that gate.
Exactly. It's not just the address, it's the credentials. If that file is wrong or missing, or the credentials aren't valid for the cluster you're targeting, Kubectl simply won't be able to talk to the API server. Access denied.
What about managing multiple clusters? Or different users on the same cluster? Does kubeconfig handle that?
Yes, it does. That's where the concept of context comes in. A context within the kubeconfig file is basically a named combination of a cluster, a user, and optionally a namespace.
Ah, okay.
So you can define multiple clusters, dev, staging, prod, and multiple users, your personal account and admin account, in one file. Then you use Kubectl config, use context name to quickly switch which cluster and user identity you're currently operating as.
That sounds incredibly useful for real-world scenarios.
Well, it's essential. Keeps things organized and helps prevent accidentally deleting your production database when you thought you were on dev.
Yeah, definitely want to avoid that. So Kubectl uses the context, finds the server and credentials, and then it sends these API requests. You said they're standard RESTful requests.
Yep. Get to retrieve information, post to create, PU, or patch each to update, delete to remove resources. Pretty standard web API stuff.
And always over TLS.
Should be, yes. Communication with the API server is typically configured to use HTTPS, providing TLS encryption. This protects the data in transit, the commands you send, the data you get back. You wouldn't want sensitive configuration or credentials flying over the network in plain text.
Makes sense. And the API server doesn't just trust the request, right? It checks credentials.
Always. Authentication first.
Mhm.
The API server needs to know who is making the request. Kubectl presents the credentials found in the kubeconfig. Maybe it's a client certificate, maybe a bearer token like a session token. The API server validates these.
And there are different ways to handle that authentication.
Lots of ways. Client certs, bearer tokens, static password files, less recommended, and integrations with external identity providers through things like OIDC. That lets you use your corporate login, for example.
Okay, so the server knows who I am. What about what I'm allowed to do?
That's the next step, authorization. Just because the server knows who you are doesn't mean you can do anything you want. Kubernetes uses role-based access control, or RBAC, heavily.
RBAC, I've heard that term.
So administrators define roles, which list permissions like get pods or create deployments, and role bindings, which assign those roles to specific users or groups. When your authenticated request comes in, the API server checks the RBAC rules. Does this user, with these roles, have permission to perform this action on this resource in this namespace?
So it's very granular.
Extremely granular. You can get very specific about who can do what, where. This is fundamental for security in multi-tenant clusters or large organizations. It prevents users or automation from accidentally or intentionally messing with things they shouldn't.
So putting it all together again, let's trace Kubectl get pods one more time, focusing on the security flow.
Okay. 1. You run Kubectl get pods. 2. Kubectl reads the current context from kubeconfig to get the API server URL and your user credentials, say a bearer token. 3. It sends a GET request to epiv one namespace of default pods, assuming the default namespace, over HTTP STLS. It includes the bearer token in the HTTP headers for authentication. 4. The API server receives the request over that secure TLS connection. 5. It validates the bearer token authentication. Is this token valid and who does it belong to? Let's say it confirms you are user Alice. Sex, it checks RBAC policies, authorization. Does user Alice have the get permission for pods in the default namespace? Let's say yes. 7. The API server retrieves the pod data from a Karthbrewer. 8. It sends the pod data back as JSON in the HTTPS response, again over the secure TLS connection. 9. Kubectl receives the response, parses the JSON, formats it as a table, and prints it to your console.
That really clarifies the layers involved. Authentication, authorization, encryption. It all happens seamlessly for every single command.
Exactly. It's designed to be secure by default, which is crucial given the power Kubernetes wields. It's a sophisticated dance, ensuring efficiency and security go hand in hand.
What an incredible tool. So to wrap up, we've seen Kubectl as this indispensable command line interface. It's the user-friendly, secure bridge to Kubernetes.
Right. It simplifies those complex interactions, making Kubernetes manageable whether you're just learning or managing huge clusters. It puts the control right there at your fingertips.
It really abstracts away so much complexity, letting people focus on building and running applications, not just wrestling with the infrastructure.
Mastering Kubectl is, well, probably the most fundamental skill for anyone serious about working with Kubernetes today. It's where your instructions meet the cluster.
So a final thought for you, our listener. As containerized applications become even more central, as systems inevitably grow more complex, how do you see tools like Kubectl evolving?
Interesting question.
Will they integrate more AI, maybe suggesting commands or spotting issues? Could they become even more abstract, letting us manage things at an even higher level, perhaps thinking less about individual pods and more about entire application lifecycles?
Could we see more natural language interfaces layered on top? Or tighter integration with GitOps workflows?
Definitely something to think about. Where does the user interface for complex orchestration go next? Thanks for diving deep with us today.